quadratic functions and how to graph them. And you guys have seen quadratic functions before. They are functions with an exponent of 2. And they are of the form ax squared plus bx plus c. And I forgot to put f of x equals, so we'll just put that there. And a can't be 0. And the reason a can't be 0 is because you have to have that x squared. Okay. The quadratic term is the ax squared. The linear term is the bx. And the constant term is the c. And it's a constant because constants are just a number with no variable. Of a quadratic is a parabola, which is a u going up or a u going down. That's a parabola. If your parabola is going up, a is positive. And if your parabola is going down, a is negative. So if we look at this graph here, I have 3x squared, which 3 is positive, so I can tell immediately that it's going to be an upwards u. And that's going to help me figure out how to graph it. And the easiest way to start is you can make a table. And you start picking picking numbers to plug in for x. So if I plug in 0, I get 3 times 0 squared minus 12 times 0 plus 6. So y would be 6. And I put a dot there. And I recommend always, like as you find points, start putting the dots immediately because that tells you which way to go as far as your numbers, whether to keep going positive x's or negative x's, because you'll start to see the shape. So the next one I'm going to try is 1, because 1 is easy. 1 squared minus 12 times 1 plus 6. So this is 3 minus 12, so that's negative 9, plus 6, negative 3. So 1, 2, 3. Now, if you look at this, it's gone down. And I know that my graph is going to be a upwards facing parabola. So if I'm going down, I need to find the curve to where I start to go back up. So I'm going to keep going in the positive direction. It wouldn't make any sense to start going in the negative direction because I'll just keep going up and up and up. Does that make sense? Okay, so I'm going to try 2. So I've got 3 times 4, which is 12, minus 24, so that's negative 12, plus 6, so that's negative 6. So I put a dot, and then I'll go to 3. And I get 3 times 9, so that's 27, minus 36, so that's negative 9, plus 6 is negative 3. And there, I found my curve. Do you see that? Now, parabolas are symmetric. Okay, so if you look here, here's my vertex. The vertex is the point where it changes directions. And then if I go up the line of the vertex, you'll see that each of these is 1 away on either side. So to get my next point, I can just keep going up, and then I go 2 over, so I would go 2 over. And now I found like a nice U shape. And you want to make sure, graph it with a fat line. It doesn't have to be perfect, but you do have to have a U, not a V. really hard to do with this pen. Okay.
How many places did you go over the top part?
2, because here was, if you look, here's the line of the vertex, and so I'm 1, 2, so I go 1, 2. Okay, and just be sure that this is a U, not a V. Okay, that's really important because a V is for absolute value, so it's a totally different graph. This way, and then I'll show you another method. So here we have a -2, so this graph is going to go downwards. And it's always good to identify that first before you start plugging in points, because it helps you to know which way to go. And I always plug in 0 first because, well, 0 is easy and we like that. So I get -3. So 0, 1, 2, 3. And then if I plug in 1, I get -2 plus 8, so that's 6 minus 3 is +3. And as you can see, I'm on an upswing here, so you can tell like the graph is going to do something like that, right? So I'm going to keep going in the positive direction. So I have -8 plus 16, which is 8, minus 3, that's 5. So I have -18 plus 24, so that's 6, minus 3 is 3. And there, I found my vertex, so I found my U. And then if I go 1 over and come down, I'll be symmetric. And then I just draw my parabola. That's okay. There's another method. The axis of symmetry is the line that goes down the center of a parabola. Okay, and it splits it in half. Okay, equally. Now we already talked about the vertex is the point where the parabola curves or changes direction. And the axis of symmetry is through this line, or through that point. Through has an H on it. Okay. Now, when you're graphing with the axis of symmetry, you use this format, y equals ax squared plus bx plus c. The formula for the axis of symmetry is we take whatever number is here for b, and we take -b, and we divide it by 2 times whatever number is here for a. And this gives us a line at x equals that point. The vertex of the x-coordinate is the same because it goes through the vertex. So the x-coordinate vertex is the same as the axis of symmetry. The y-coordinate of the vertex, you plug in the x-coordinate and solve for y. And then the y-intercept on the graph is just c. The axis of symmetry. If there's no number here, this is 1. That's A. B is 4 and C is -3. So first we want to find the axis, which is -b over 2a. So it's -4 over 2 times 1, or -2. So once I found that line, I'm going to go to -2, and I usually just draw a dotted line. I don't like that one. At -2, that's my axis of symmetry. So my parabola is going to be equal on either side of this line. So this is my axis of symmetry.
You have to draw that line.
You have to draw a line of some sort, just like it doesn't have to be like just a faint dashed line down -2. So that's the first step, step 1. Step 2, I know that my vertex coordinate is going to be the same as my axis symmetry for x, so I need to find y. So I plug in -2. So I have 4 minus 8, so that's -4, minus 3, so that's -7. So my vertex is at -2, -7. So I go down to -7, and I draw a dot. And then my third step is to find my y-intercept, which is C. So on my y-axis, I go to -3, and I draw a dot. Now, there are 2 spaces between this dot and the axis of symmetry. So I'm going to go 2 spaces over and make another dot. And 3 points is enough to make a U. Now, if you were graphing this to find the solutions, I would say go out a bit further so you get more accurate. But since you're just graphing it just to graph it, you've got your 3 points. That's plenty. Make a U, and you're done.
Did you get the 2 points in the side?
Hold on 1 second. So this point here was my y-intercept, which is just C. So I went on the y-axis and plotted that point. And then you can see how this is 2 spaces from your axis of symmetry. So I went 2 spaces over and made another point. So with plotting points and doing a T-chart, you can end up having to do a lot of steps, but with using axis of symmetry, it's like 3. But it's going to be the same process, even though it's negative. The first step is to find the axis, which is -b over 2a. So I'm going to have -10 over 2 times -5. So that's 10 over -10, so that's -1. So I'm going to go to -1 and make my axis. Okay. So then I need to find the y coordinate of the vertex. And to do that, I'm going to plug in, yeah. So I have -5 plus 10, so that's 5, plus 6 is 11. Uh-oh. 4, 5, 6, 7, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, I've made it. So there's 11. My y-intercept is 6. I'm just doing this so I can see better. So I have one space. So I'm going to go one space. And this is going to be a skinny U, but it's still going to be a U. Okay, if A is negative, you're like this, right? So you have a maximum. If A is positive, you're like this, so you have a minimum. And that's because if you're going down, your highest point is going to be your vertex. You can't go above that. So that's why it's a maximum. And if you're going up, your vertex is your lowest point, which is a minimum. So this particular function has a max because it's negative. To state the minimum or maximum value, that's the y-coordinate of the vertex. That is the minimum or the maximum. So step 1 is to plug in to find the x-coordinate. And then step 2 is to plug that in to find y. So if x is -b over 2a, so it's going to be -12 over 2 times -4. That's not fun. So I'm going to get -12 over -8, which is -3/2. Sorry, guys. Or +3/2. Sorry. I gave you guys a fraction. Didn't mean to. Okay, so then I need to plug that in. But the fractions will go away. Okay, so 3/2 squared is 9/4. And 4 goes into 4 once, so that will be -9. And 2 goes into 12 6 times, so that will be plus 18 plus 18. So -9 plus 18 is 9. 9 plus 18 is 27. So this is my maximum. The domain in quadratics is either all reals or you can use the symbol for all real numbers. The range is going to be either y is greater than or equal to the minimum or y is less than or equal to the maximum. And it's always going to be that way in a quadratic. So in this particular instance, the domain is going to be all reals, and the range is going to be y is less than or equal to 27 because we had a maximum. All right, so if we look at this other example, it's positive, which means it's going to go this way, which means it's going to have a minimum. Okay, and then when we find the minimum, I first have to use my x formula. So I have -24 over 2 times 4. So that's 24 divided by 8, so that's 3. And then I have to plug in to the actual formula that I'm given. So I plug in 4 times 3 squared minus 24 times 3 plus 11. So this is 4 times 9 minus 72 plus 11. So that's 36 minus 72 plus 11. So that's -36 plus 11, so that is -25. So my minimum is -25. So far, okay? And then domain and range. The domain is always the same. All real numbers. And then your range, because I have a minimum, it's going to be y is greater than or equal to the minimum. So if I had a maximum, it's less than or equal to. If you have a minimum, it's greater than or equal to. You can use parabolas. Parabolas will mimic real-world situations. A lot of time when you're talking about projectile motion, that's parabolas. And things like you can use like the equation of a parabola to determine where something will land and things like that. Well, this one is that Eddie is organizing this charity tournament, and he was going to charge $20 for 80 people, and then he decided to raise the entry fee by $5, and 5 fewer people entered. So he was going to determine like how to maximize the amount of money he raised for charity by assuming that every $5, 5 less people would join. And so you get this graph based off of that. So what we want to do is we need to find out what is the equation of this line so that we can find out what the maximum value is. Now, he's charging $20 to start, but he wants to raise it by 5, and we don't know how many times he's going to raise it by 5. And he had 80 people to start, but every time he raises it by $5, he loses 5 people. So this is how much money is bringing in, and this is how many people are coming in. Does that make sense? So to find the equation of this, I'm actually going to multiply these two things together. And if I FOIL this out, I'm going to get 1600 minus 100x plus 400x minus 25x squared. So my formula is going to be negative 25x squared plus 300x plus 1600. To find the maximum, I first need to find the x value of the vertex. So I'm going to do negative 300 over 2 times negative 25. So that's going to be 300 divided by 50. So it's 6. So then to find the maximum, I'm going to plug 6 in here. So negative 25 times 6 squared plus 300 times 6 plus 1600. Okay, and you know, honestly, can't do 25 times 36 in my head right now. So I have negative 900 plus 1800 plus 1600. So he's going to raise $2,500.